Okay, so I'm going to look at part of the lesson that we couldn't do today online, and I'm going to show you four of the circuits that you need to know when using a transistor as a switch. You need to know how you can switch something on when it gets dark, how you can switch something on when it gets light, how you can switch something on when it gets hot, and how you can switch something on when it gets cold. So I'm going to start with this circuit at the top. This is what we've looked at before. I've got a large resistor here. I've got a variable resistor at the bottom. I've got my transistor here, an NPN transistor. Now, if you don't understand how this works as a switch, then you can watch the last video. And I've got a buzzer here. This could be a motor. It could be a light, it doesn't matter. This is called a load. This is the thing that we want to switch on and off, and it can be anything. Motor, buzzer, light bulbs, LED. It entirely depends what you want the circuit to do. There's one little extra thing that I put in this circuit this time, and that's a little protecting resistor here. This resistor here, just same as we do with an LED, it just stops too much current going into the transistor and blowing it up. So it's just there for a little bit of protection. Now, what happens in this circuit, if you remember, is here I've got 9 volts, 0 volts here. I've got a big resistance here, so it drops from 9 volts to 0 down here. I've got no resistance here, so it just works as a normal wire. So I've got no voltage there at all. If I put a voltmeter on here and connect it up, you can see I've got no volts there. As I increase the resistance down here, what happens is that less of this 9 volts disappears over there. So I'm now dropping 8 and a bit volts over here, and I'm dropping 0.2 volts over this bit. Now that bit you don't have to remember or know at the moment. We can do some more work on that. But what you need to know is as I move this slider up and I get more resistance down here, the voltage goes up here. So the voltage between this thing here called the base and the 0 volts is going up. And when it gets to 0.7, the transistor switches on. And when the transistor switches on, it means that the load, this thing up here, so in this case it's a buzzer, the buzzer will switch on. So I can, by varying the resistance down here, I can switch this buzzer on and off. Now that's a bit useless really, because I might as well just have a switch to do that. But what it means is, if I put a sensor down here instead of a variable resistor, so something that senses light or heat, then it could work by itself, changing the resistance as it gets lighter and darker, or as it gets hotter and colder, and it will switch this buzzer on and off automatically. So what we're going to look at is going to look at the 4 circuits that you need to know about. So I've got my components down here. This bit here is always going to stay the same. This bit here is always going to stay the same. So that's my 9 volts going into the circuit, and this is the transistor and the load that are going to switch on and off. These are the bits down here that I'm going to work on. I'll always have a large resistor so that I get something called a potential divider. And this resistor, first off, we're going to attach as we have in the top circuit. The bottom bit down here is going to attach straight to 0 volts. Now this won't go on, the buzzer won't go on because this switch is off. The transistor is off because I don't have 0.7 volts across the base input here. Now what I can do, if I want to detect light, I can use this. This is a light dependent resistor. So I can put a light dependent resistor on there, connect it up, and connect this to it. So let me just mess about with the construction a little bit. So what happens now is this light dependent resistor, as you can see, there's light on it, so it's got a really low resistance. It's only 400 ohms. So it's like this circuit up here with a low resistance. When it's got a low resistance here, the buzzer is off. When I get a high resistance, the buzzer goes on. A light dependent resistor, when it gets darker, you can see the resistance starts going up. So the resistance is going up and up, and then when I get to a point where this goes to 0.7 again, the transistor switches on and the buzzer switches on. So I could grab myself another voltmeter if I wanted to. I can put it on here just to check that that's the case. You can see I've got a really low voltage here. As the resistance goes up, this voltage goes up, and when it gets to 0.7 or 0.69 in this case, the buzzer goes on. Okay, so there's a little bit of tolerance there. It depends what the transistor is, but basically anything above 0.7 and it goes on, anything below and it switches off. Okay, I'm going to copy this circuit and put it over here. Now, if I wanted to detect temperature instead, I would use this thing here. This is called a thermistor. And this, I can adjust the temperature here going into the thermistor so that you can see what happens. So I'm going to delete my light dependent resistor, put the thermistor into the circuit, like that, join it up. Let's just put the wire on there, like this, and join the whole thing up. Okay. So if you remember, when the resistance is low, like that, the buzzer is off. So down here, you can see if I increase the temperature on a thermistor, the resistance gets less and less. So when it's hot up here, this whole circuit is off. When it gets colder, the resistance goes up. And remember, when the resistance goes up, all of a sudden the buzzer turns on. So the resistance down here is getting more and more, and all of a sudden the resistance is high enough that this will turn on. Now the reason for that again is because the voltage across the base is suddenly going to 0.7. So you can see at the moment that's 20 degrees, and at 20 degrees the voltage here is 0.2. As the temperature drops, the resistance here is going up and the voltage here is going up. So we've got to 0 volts there and going down about minus 10. So about minus 10, all of this switches on. Now, it's not always going to be minus 10. I can adjust what kind of thermistor I use. I can adjust this resistance up here. But at the moment, we don't need to look at that. All we're going to look at is the fact that I can switch a buzzer on when the temperature gets cold, and I can switch a buzzer on when it gets dark. Now what I need to do is I need to be able to switch them on when it gets hot or when it gets light. So what I'm going to do is I'm going to copy these two circuits so that I can look at them again. And then what I'm going to do is I'm going to swap these two components over. So I'm going to get my 50k resistor and my light dependent resistor, and I'm going to put the light dependent resistor on the top now, and I'm going to put the large resistor down here at the bottom, connect it up like this, and you can see it's light and the buzzer is on, and as it gets darker the buzzer switches off. So what I've done by swapping these two over, I've reversed what happens. On this one, dark, the buzzer is on, light, the buzzer is off. On this one, dark, the buzzer's off, light, the buzzer's on. Now, we'll do lots of work showing you how to work that out exactly, and showing you what's happening here to change the voltage. But if you remember, it's always the case that, if I put a voltmeter down here, when the voltage across the base of the transistor gets to 0.7, it will switch on. And as this goes up, you can see 0.72, it's gone on, below 0.7, and it switches off. I can do the same for my thermistor. So same thing, I'm going to swap them around. I'll put my 50k down there, and I'm going to put my thermistor at the top. Now, thermistors are a bit odd. Sometimes you need to juggle about with the resistances a little bit, but we'll have a go on this one. Put it down there like that, and you can see that it's on at the moment. It stays on while it's cold, and it won't switch on when it's hot. And I want it to be switching on when it's hot. Now, the reason for that is that I need to adjust the potential divider here and make sure that this voltage here will change to 0.7 volts. So you can see at the moment, when I'm moving this, it's only changing between 0.73 and 0.72. I can't get it to drop down low enough. So I can mess about with this resistance down here. So if I make it 100 kiloohms, like that, I can see I'm still not making any difference. So what I could do is drop it down maybe, see what difference that's going to make. And I've managed to drop it down to 0.71. I don't really want to drop this resistor any lower than that. So what I'm going to do is I'm going to pick a better thermistor. And I'm going to pick a thermistor that will give me a larger range. So you can hear it's gone off now. And you can see that I've adjusted the range that this thermistor works on. So it's working now from 50k all the way up to 932k. But now it's off all the time. So I'm really having to mess about with this, and this is always the most awkward circuit to do. But it's why you can work this out with some equations, and I'm going to show you those in the future. But at the moment, we're just playing about with it until we get this to switch on. So I'm going to try different variations of resistance on here and see what we get. I've got it on again there, and it's switching off here, and it's switching off at about 7 degrees, something 7-8 degrees, something like this. So that means I can adjust the two resistances here to get it to switch on and off at different temperatures. I could do the same thing up here. That's switching on at -10 about, and if I change the resistance on the thermistor, use a different thermistor, or I change the resistance on this big resistor up here, I could get this to switch on and off at different temperatures. Okay, so it's quite a long explanation, but basically this is your basic circuit. I can then change the variable resistor and put a light dependent resistor on and get it to switch on when it is dark. So light dependent resistor on the bottom, it will switch on when it's dark. If I use a thermistor on it to push that up, this will switch on when it's cold. If I put the thermistor at the top here, it will switch on when it's hot. If I put the light dependent resistor at the top, it will switch on when it's light. So those are the 4 circuits that you need to know about. Now I know it's a long explanation, but hopefully you can rewind, you can go through it a few times, and obviously you can do some research on the internet. I'm going to try, as I've said before, to see if I can either change the license on this or use a different piece of software so I can explain this to you while we're working on the lesson. But if you've got any questions, you can just type it into the chat that goes along with this video, and I can answer them for you.